we had the opportunity of constructing 9 maths learning aids to teach concept of mathematics throughout the primary level. We had the opportunity of working together, myself and teammates. We are Ms. Shani Sned, Ms. Rihanna Mohammed, Mr. Fane Forrester, Ms. Umade Grant, Sir Courtney Backus, and yours truly, Alan Austin. My task was to create the rectangular and circular geoboard in teaching maths concept at the grade 5 level. Now, there are various concepts that you can teach at use the geo rectangular board to teach, some of which are perimeter and area, symmetry, 2D and 3D shapes, lines, and so forth. But today, I will be demonstrating how we can use the rectangular geoboard to teach perimeter and area. So, we would have already teach the basic of perimeter, the definition, the formulas, and so on. So, we'll use our rubber bands to construct. The first thing we'll do, construct our rectangle. So I have this rubber band and I'm going to put it around these pegs to form a rectangle. So you'll have them punch the spaces. So we know that a rectangle, the perimeter of a rectangle is the distance around the rectangle. So we'll count the spaces and we count the distance around the rectangle. So I have 1, 2, 3, 4. You can have them write it. So for the length we have 1, 2, 3, 4. 4. Then with 4 units. Then we have for the width we have 1, 2. All the length 1, 2, 3, 4. Perimeter of this rectangle. You can have them manipulate with some other size of rectangle. You can extend the rectangle and let them do the same thing. They count the number of spaces or the number of units for the length and for the width and have them add them up. Alright, so that's for perimeter. We can use the same rectangle to find the area. So we know that the formula for finding area of a rectangle is length times breadth or the amount of small squares within that given shape. You can have them count the number of squares by making the squares. So we have this one small square there. Then we have the other one. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, 121, 122 breadth. So you have the length would be 1, 2, 3, 4. So length will be 4 and the breadth or width will be 2. 1, 2, 2. So 4 multiplied by 2 will give us 8. 8 cm squared. So even though we count the small squares in the shape and then we use a formula, we end up with the same answer. Good. So that's it for how we can use the rectangular geoboard to teach maths concept at grade 5 level. Now, I have another board here for you. This is called a circular geoboard. So the circular geoboard, you can also use this board to teach maths concept, and you can use this geoboard to teach circular vocabulary. So I'll take this rubber band and I'll put it around the circle. Let them know that this is the perimeter of the circle. And we call this, it's a special name given for this, it's called the circumference. Now also, we can use it to show them the diameter, which is a line that passes through the center of the circle to the other side of the circle. So we have the diameter here, and we can see that the diameter form semicircles or 2 half circles. Alright, then you can use it also to show them the radius, and you can ask them what you recognize there, what you observe there, and they can tell you, oh miss, this is half of the diameter. Yes, it is half of the diameter, and the diameter, the radius is from one end to the center of the circle. Then we have the sector. The sector is like a piece of the pie, piece of a pie or a slice of a cake. Right, this is the sector. Sector. Let's see. Sector. And we have, so this is the sector of the circle. And then we can make the chord. The chord passes through one end to the other, but it does not pass through the center. It passes through the center, so the chord does not pass through the center, so the chord is a line that does not pass through the center. So this could be the chord. This could be the chord. As long as it does not pass through the center, it's considered chord. Good. So we have here the vocabulary of a circle being done here, and this can be done at a grade 5 level. Thank you. I will now hand you over to my other colleague who will take you through the other aspect.
Good evening, everyone. My name is Courtly Bacchus, and I will be talking about the Chinese tangram. Good. Now, for the persons that are wondering what a Chinese tangram is, it's basically a puzzle, as you can see here, made up of various shapes, plane shapes, I should say. There's two large triangles. There are 2 small triangles. There's a square, a parallelogram, and one medium-sized triangle. Now, when they are assembled, as you can see here, it was cut out of a square. All right. Different angles and when you put them together you get a square. Now this Chinese tangram is not only for entertainment, but it can also be used educationally, as they develop spatial reasoning, problem solving skills, and creativity. Right? Now, for the persons that are wondering what spatial reasoning is basically the ability to visualize, manipulate, and understand the relationship between objects in both 2-dimension and 3-dimension spaces. All right. Um, it also helps with skills for everyday life, such as navigating unfamiliar places, assembling furnitures, or even packing suitcase efficiently. Now, for the grade 6 level, a Chinese tangram can be used for so many things. It can be used to show relationships between shapes, as you can see here, right? It shows basically that 2 halves equal to 1 whole. Here you can have equivalent fractions coming out. Yes, the Chinese tangram can also be used for creativity and innovation. Here we can use the Chinese tangram to create a home, as you can see here. Yes, here you can see a home being created. It can also be used to create animals. Now, as you can see here, a turtle is being created. Basically, the Chinese tangram, it works nice at the grade 6 level, reason being because it helps with their geometrical skills. Tangram helps students to understand and apply concepts like congruencies, similarities, symmetries, and area. Alright? It helps with spatial reasoning. Now, how it helps with spatial reasoning? Working with tangrams enhance spatial awareness and understanding of how objects relate to each other and the space they occupy. Now, problem solving skills. Tangram presents puzzles that require students to think strategically, right, and creatively to find solutions, as shown earlier, where they had to think of ways and means of how to create a turtle or create a house, right? It can also create letters. The variety of things that it can create, it is wide. All right. Now, thank you for listening, everybody. I'll now hand you over to my other colleague, which will be looking at the fractional wheel.
Hello everyone, my name is Omide Grant and I'm tasked to construct a fractional wheel which I'll be using to teach a grade 2 lesson. Now we have a whole, 1/8, which is one part out of a whole, 2/8, which is two pieces out of a whole, 3/8, three pieces out of a whole, 4/8, 4/8, which is actually the same as half, 1/2. 5/8 is 5 pieces out of a whole. 6/8 is or 6 pieces out of a whole. 7/8, 8 pieces out of a
Good afternoon, everyone. So I was tasked to construct the attribute logic set. What is the attribute logic set? The attribute logic set is a mathematical manipulative used to help students develop logical thinking, classifications, skills, and understanding of mathematical concepts such as sets, sorting, and even early algebra. This logic set, right? It helps children visually and physically explore concepts of sorting, as I mentioned before, classifying, pattern, comparing, and reasoning. So, today I'll be looking at grade 1. So for grade 1, they'll be doing sorting and classifying by one attribute. The objective is for the pupils will sort and classify objects based on a single attribute such as color, shape, or size. So if you're going to give them the activity, it will go like you will give the pupils a set of attribute logic blocks. Then you will ask them to sort the blocks by color, whether you want them to put all the red together, all the blue together, all the black together, all the white together. Then they will sort by shape, whether they are circle, triangle, square, rectangle. And finally, they are going to sort by size, whether they are big, small, or medium. So with this attribute logic set, you can use it to teach the various subjects like algebra, even grouping. You can use it to teach sets with the Venn diagram, like I mentioned before. So an example of the Venn diagram, using the Venn diagram, they can sort blocks by color and shape, like I mentioned before, with squares. So they can put the red squares in one circle and then they put blue squares in another circle. So that is grouping by color.
Here we have a 1 meter trundle wheel. This wheel helps us to measure the distance of somewhere. Let's say a play field or the ball field, or you can give the children to measure their classroom. So how this wheel works. So first we have to make sure that we align the numbers accordingly. The 0 must be the number which is touching the ground. So here we see we have the 7, so we can rotate it a little to make the 0 touch the ground. Then we will try our best to push it along a straight line. And each complete rotation, that means that we would have complete 1 meter. So here, let's go. So we're pushing it along and the 0 makes contact with the floor again. So that means that we would have complete 1 meter. If we keep pushing and the 0 touches the ground again, that means we would complete a whole another meter, which would be 2 meters. We can also use this ruler in the way of, let's say we're measuring our play field, which would be a rectangular area. So we will move it, the 0, and let's say it didn't complete a rotation, but we have to make a turn. We just spin it and we continue rolling until we get and we touch the ground again with the 0. And that is how we use the 1 meter trundle. Here we have our mathematical balance. A mathematical balance is an instrument that we can use in our maths class in grade 1 through 4 to help them to understand the concept of more than, less than, equal. So here we have our weights, and we have some flashcards. So let's say we're in a mathematical class. So we would place one weight at number 5, and then you see it tilts a little, and then we would place the other at number 5. And we would ask the class, what just happened? So here the mathematical balance stays the same. But let's say we take another weight and we place it on this side at number 3. What do you see happening there? The mathematical balance, it would have tilted this way. Why is that, you may ask? Because we have 3 plus 5 over here, which would be equal to 8, and we have 5 over here only. So that tells us that 8 is more than 5, because the balance would have tilted to the side which has 8. So we remove these. And how do we use it? Using the flashcards. So we can give the kids some flashcards. Here we have a problem. It says 7 equals to 5. So on one side, we would place our weight at 7, and at the other side, we would place our weight at 5. So did it tilt towards the 7 or towards the 5, or is it equal? So it tilts towards the 7 because 7 isn't equal to 5, right? And we can also show them by counting and showing them that on our fingers we can say 1, 2, 3, 4, 5, 6, 7. We would show them this, then we would count to 5, 1, 2, 3, 4, 5, and ask them if we have the same numbers of fingers up. So when this balance tilts, it tells us that either the number is greater than the number which is on the other side. So when they see this, they will be able to say, no, 7 is not equal to 5. We can use this throughout grade 1 to 4, and we can also use word problems. We can ask them, Sam has 6 mangoes. Jenny has 7 mangoes. Then we ask them, who has more mangoes? So we know that Sam has 7 mangoes. So we can count, or if they are able to identify these numbers, we place it on 7, right? Because Sam has 7 mangoes. And you see, because here is empty, it will tilt that way. So now we look for the number 6 and we place the weight at 6. So did it move? No. It continues to tilt that way because 7 is more than 6. So they're able to answer the problem and say that 7